In this video, we'll be learning about locating points at a specific distance. So for this problem, it says find all of the points with the x-coordinate 1, which are 4 units from the point 3, 2. So let's draw our graph. So we have our point right here, 3, 2. And we have our other point, which has an x-coordinate of 1, and then it has an unknown y value. So we'll label this y. So the x-coordinate is going to be 1, but the y value we don't know. So let's go to 1 for the x value, and we're going to graph x is equal to 1, basically. Because we know the x value is going to be 1. It's going to be exactly 1. It's always going to be 1. But the y value we don't know, so we can draw a line up and down, showing that we don't know what the y value is, but we know what the x value is. So the point has to be 4 units away from this point, 3, 2. So it can be anywhere on this line. So it can be here, 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 but we're not sure as long as it's 4 units away from each other. So that's essentially what we're trying to figure out. Now let's substitute each value with a variable. So let's put our 2 points. We have 1, positive y, and then we have 3, 2. Then we're also given the distance between the 2 points. So it's going to be d is equal to 4. So we're given 2 points. So we can label this first point as x sub 1 and y sub 1. And then the second point as x naught and y naught. So we have to use the distance formula here because we're given distance and 2 points. And one of the points is one of the values is unknown, which is y sub 1. So the distance formula is going to be the square root of x sub 1 minus x naught and all that squared plus y sub 1 minus y naught, all that is squared. So when we plug in our values, we get 4 is equal to the square root of x sub 1, which is 1, minus x naught, which is 3, and then squared plus y sub 1, which is y, minus y naught, which is 2 squared. And I forgot to disclaim this, but it doesn't matter which point you label x sub 1 and y sub 1, or whichever values you associated with. So you can label this point y, 1 as x naught and y naught. It doesn't matter as long as the other point, this 3, 2 point, is x sub 1 and y sub 1. So it doesn't matter which one you label x naught or y naught. You're still going to get the same answer. But for this problem, I labeled the first point x sub 1 and y sub 1. So we have to do a little bit of algebra here. Essentially what we're trying to do is we're trying to get the y on one side of the equation and find what y is equal to. Now we're trying to get y by itself, but y above y we have a square root. So what we need to do is square both sides. And the reason why that works is, let's say we have 4 square root and then we have in parentheses of all that squared. You can write the square root of 4 as 4 to the power of 1/2. And then we have our parentheses and then squared. Essentially what's going to happen is these exponents are going to multiply each other. So it's going to be 2 times 1/2, which 2 times 1/2 is going to give you 1. So it's going to be 4 to the power of 1, which is 4. So whenever you square a square root, you just get whatever is inside of the square root. So we have 4 squared, and then remember the square and the square root are going to cancel out. So we get whatever is inside. So we get 1 minus 3 squared plus y minus 2, and then squared. Now we can evaluate some of these expressions. We have 4 squared, which is 16, and then we have 1 minus 3, which that's negative 2, and then we carry the squared. And then y minus 2 we cannot simplify. The reason why is because y is a variable. Y is an unknown value. So there's no number associated to that. So we can't simplify that anymore, at least inside the expression. So we're just going to leave it as y minus 2 and then squared. Oops, did not mean to erase some of the square root. Whatever, I'll just leave it like that. So we have 16 is equal to, and then we have negative 2 squared, which is 4, and then plus y minus 2 squared. So we need to get y on the side by itself, and we need the numbers all on the other side. So we subtract both sides by 4. So 16 minus, we get 16 minus 4, and then we have 4 minus 4 right here, which that's just 0, so we don't even need to write it. So we get y minus 2 and then squared. So 16 minus 4 is going to give you 12. Then we have equals y minus 2 squared. Now, we need to get rid of the squared that's in parentheses for y minus 2, or above the parentheses. The reason why is because we're trying to get y by itself. So we need to square root both sides to cancel out that squared. We use a square to cancel out a square root, and you can do the other way. You can use a square root to cancel out a square. So we square root both sides, and we get the square root of 12 is equal to, and then remember, whenever you have a square or square root together, you're just going to get whatever is inside. So we get y minus 2. So we need to get the 2 that's by y, the negative 2, we need to get it on the other side. So we add both sides by 2. So you get the square root of 12 plus 2, or you can write 2 plus the square root of 12. Each way works. So then we have equals y, and then we have negative 2 plus 2, which that's 0, so we don't need to write that. Now we can simplify the square root of 12. So we have y is equal to 2 plus, and then we have the square root of 12. So essentially what we want to do is we want to pull out a number for the square root, or not pull out, but we want to factor out a number for the square root and then simplify that and take the square root of that. So for example, we want to pull out the perfect square root. So let's say an example of a perfect square root is the square root of 4. That gives you plus or minus 2. Square root of 9 is another one. It gives you plus or minus 3. The square root of 16 gives you plus or minus 4. So what we want to do is we want to factor out the highest perfect square root. So we can try the square root of 4. Can we factor out a 4 out of 12? Yes, we can. So what we can do is say we have the square root of 4 times 3. And remember, 4 is a perfect square root. And what we can do next is we can split this apart into 2 square roots, since it's 2 numbers getting multiplied by each other. So we have the square root of 4 times the square root of 3. Now remember, we know that what the value of square root of 4 is. It gives us a whole number. So we have 2 plus, and then we have square root of 4, which that is going to be plus or minus 2. And then times the square root of 3. Now, we can clean this up a little bit since I put an extra plus, so it's y is equal to 2 plus or minus 2 times the square root of 3. And that is your answer. So you get 2 values. You get y is equal to 2 plus 2 times the square root of 3, and you get y is equal to 2 minus 2 times the square root of 3. So those are 2 y values where if you plug that in on a coordinate plane and you plot a y value and it has that x coordinate 1, and one of these y values you plot, you're going to get that point that you plotted. It's going to be 4 units away from the point 3, 2. So the problem wanted us to find the points that has this y value to where it's 4 units away from the point 3, 2. So this was our original point, 1, y. But we have our calculated y value, so we can substitute that in and find the exact ordered pair where it satisfies the conditions in the problem. So we have 1, and we have a square root, so that means we're going to have 2 different answers. We're going to have the plus version, and then we're going to have the minus version. So let's do the plus version. So it's going to be 2 plus 2 times the square root of 3. So this is going to be our first point. And we have our second point, 1, and then we're going to do the negative version, 2 minus 2 times the square root of 3. And that's going to be your second point. So those are your answers. So for this problem, it says find all of the points of the form x comma negative 1, which are 4 units from the point 3 comma 2. So let's draw our graph to help us visualize this. So we have our point right here, 3 comma 2. And then we have the other point, x comma negative 1. So we don't know the x value. The x value can be any value on the graph, but we don't know it yet. But the y value is going to be negative 1. We're sure of that. So what we can do is we can draw a line at y is equal to negative 1. And we can draw that because we don't know the x value, but we know that the y value is negative 1. So the point is going to be somewhere where the y value is negative 1. And then some x value, which we're not sure yet. Now these 2 points have to be 4 units away from each other. So it can be here, 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 or basically anywhere on that line, but we don't know yet. But the distance has to be 4. So we're given 2 points, x comma negative 1, which I'm going to label as x sub 1 and y sub 1. And then we have the 3 comma 2 point, which I'm going to label as x naught and y naught. And then we're also given the distance between these 2 points. So your distance is going to equal 4. So your distance formula is d is equal to the square root of x sub 1 minus x naught. And all of that is squared. And then y sub 1 minus y naught. And then squared. So we can replace d with 4 since d is equal to 4. And then we have the square root of x sub 1, which that's x. And then minus x naught, which is 3. And then all that is squared. And then we have y sub 1, which is negative 1. And then minus y naught, which is 2. And then squared. Now, we need to solve for x. And we have a square root above x. So we need to get rid of that. So we're going to square both sides. Because remember, your square root and squares cancel each other out. So we get 4 squared is equal to, and then since the square root and the square cancel out, we get x minus 3 squared plus negative 1 minus 2 squared. 4 squared is going to give you 16. And then we have x minus 3 squared, which we can't simplify that anymore in the parentheses. So we just leave as x minus 3 squared, and then plus, and then we have negative 1 minus 2, which that's negative 3, and then squared. So we have 16 is equal to, and then we're going to leave the x minus 3 squared. We're going to take the square root of x minus 3 squared whenever we have all our numbers on one side. But we still have that negative 3 squared that we need to simplify. So we have x minus 3 squared and then plus, and then negative 3 squared is going to give you 9. So what we're going to do, I'm going to write this up here so I can show you that we're subtracting it by 9. So we're going to subtract both sides by 9. So when we do that, we get 16 minus 9 is equal to x minus 3 squared. And then we get 9 minus 9, which that just gives you 0, so we don't need to write that. So 16 minus 9 is going to give you 7. And then we have 7 is equal to x minus 3 squared. Now, we need to get rid of the squared, so we square root both sides. So we get plus or minus the square root of 7 is equal to, and then remember the square and the square root cancel out, so we get x minus 3. Now, we need x on the side by itself, so we're going to add both sides by 3. So we get 3 plus or minus the square root of 7 is equal to, and then negative 3 plus 3, right there, that's going to give you 0. So we get x on the side by itself. So that's your answer. So x can be 3 plus the square root of 7, or x can be 3 minus the square root of 7. So we have our original point that we had, x comma negative 1. And we have our calculated x value and what it equals. So it has a plus or minus sign. So we need to include that in our point. There's going to be 2 different points, basically, where the distance is going to be 4 units from those 2 points given, x comma negative 1 and 3 comma 2. So we need to plug in that x value. So we have the square root of 7, this is the positive version, by the way, plus 3 comma and then -1. So that's the first point. And then the second point is the negative version of this. So it's negative square root of 7 plus 3 comma -1. And that's the second point. So for this problem, it says find all of the points on the y-axis, which are 5 units from the point -5 comma 3. So let's draw our graph so we can visualize this. So we have the point -5 comma 3. And we're trying to find a point on the y-axis, which remember, this is your y-axis, the up and down axis, the vertical axis. So we're trying to find some point on this axis where the distance is going to be 5 units. So how do we write that? How do we write a point on the y-axis? Well, if you notice, the y-axis, the y value is up and down, right? But is it moving horizontally? No, it's not. It's just moving in a straight line up or down. So we can write that point as 0 comma y. Since it has no x value, it's not moving to the right and it's not moving to the left. It's just going straight up. That's what the y-axis essentially is. So that's how we can label that point. Now we have our other point, -5 comma 3, and we have the distance, which is 5 units. So I'm going to label the first point x sub 1 and y sub 1, and the second point x naught and y naught. So distance formula, d is equal to the square root of x sub 1 minus x naught. All of that is squared, and then y sub 1 minus y naught, and all that squared. So let's plug in our values. We have d is equal to 5, and then equals, and the square root of x sub 1, which is 0, and then minus x naught, which is -5, and then squared, and then plus y sub 1, which is y, minus y naught, which is 3, and then squared. And then we need to square both sides because we have a square root above y. So we square both sides. So we get 5 squared is equal to, and then the square root and the square cancel out. So you get 0 minus -5 squared and plus y minus 3 squared. So 5 squared is going to give you 25. And then we have two negative signs getting multiplied, so that gives us a positive sign. So we have 0 plus 5 squared, and then plus y minus 3 squared. So remember, whenever we have our variable in parentheses and it's getting subtracted or added by a number, we need to get the numbers all on one side first, and then we get rid of the square. So we have 25 is equal to 0 plus 5 is going to give you 5. So it's 5 squared, and then plus y minus 3 squared. So then we get 25 is equal to, and then we have 5 squared, which that's 25. And we have plus y minus 3 squared. Now we want all our numbers on one side, so we need to get this 25 on the right to the left side. So subtract both sides by 25. So we get 25 minus 25, which that's just going to give you 0. So I don't even need to write that. So 25 minus 25 is going to give you 0. And then we have this 25 minus 25 right here, which that's also going to give you 0. But I'm not going to write that. So we can just write it as y minus 3 squared. And then now we can take the square root, since one side is all of our numbers that aren't squared and aren't in parentheses. So we can square root both sides, and we get the square root of 0. You don't need to write as plus or minus the square root of 0, since 0 is neutral. So we get the square root of 0 is 0, and then we get y minus 3. I don't know why I wrote the parentheses. And then we need that 3 to get on the other side with a 0, so we add both sides by 3. So you get 0 plus 3, which that's going to give you 3. And then this side is going to be 0, so it's going to be y plus 0. But since 0 has no quantity, it's just going to be y. So your answer is going to be y is equal to 3. So we calculated our y value, and we had the original point 0, comma, y. So we need to put in the ordered pair form of the point. So essentially what we need to do is plug in that y value and then put it in the correct ordered pair form. So we have 0, comma, and then we replace this calculated y value for the y value in the ordered pair. So we have 3. So this is the point where if you plot it on the y-axis, this is the point on the y-axis where it's 5 units from the point -5, comma 3. So for this problem, it says find all of the points on the x-axis which are 2 units from the point -1, comma 1. So let's draw our graph to help us visualize this. So we have our point -1, comma 1. And we're trying to find a point on the x-axis where the distance between the 2 points are 2 units. So it can be here, 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 here. We just need to figure out what point is it going to be. So how do we write that point on the x-axis? Well, we know that x-axis is moving left to right, or it's moving horizontally. So the variable we're going to denote for the x value is just going to be x, because it can be any x value. We just don't know. But the x-axis doesn't move up or down. It doesn't move vertically. It just stays at one particular y value, and that's going to be 0. So we can write that point as x, comma 0. And then we have our other point, -1, comma 1. And then we have the distance between the 2 points, which is 2. So I'm going to label the first point, the x, comma 0 point, as x sub 1, y sub 1. And then the second point as x naught and y naught. So we have that distance formula. D is equal to the square root of x sub 1 minus x naught squared plus y sub 1 minus y naught squared. So D we know is 2. And then we have the square root of x sub 1, which that's x. And then minus x naught. So we have -1 and then squared. And then plus y sub 1, which is 0. And then minus y naught, which is 1. And then squared. So we have x right here, and above it is a square root. So we need to get rid of that. We need to square both sides. So we get 2 squared, and then we get the square root and the square are going to cancel out. So we're going to get x minus -1 squared plus 0 minus 1 squared. So 2 squared is going to give you 4. And then we have 2 negative signs getting multiplied. So it's going to give you a positive sign. So we have x plus 1 and then squared, and then plus 0 minus 1 is going to give you -1 and then squared. So then we have 4 is equal to, and remember we want all the numbers on one side and then we take the square root, but we still have that -1 squared that we need to simplify. So we have x plus 1 squared, so we're going to leave that there and before we move the number, and then we have -1 squared, which that's 1. And then we have 4 is equal, so I'm going to write it up here again so we can do our algebra. So we need that plus 1 on the other side, so we have to subtract both sides by 1. So we get 4 minus 1, which that's going to give you 3. Then we have 3 is equal to x plus 1 squared, and then we have 1 minus 1, which that's 0, so we don't need to write that. And now we can take the square root of both sides, since we have our numbers all on one side and then our variable and number on the other side that's getting squared, or our parentheses on the other side with the square. So we square root both sides, and we're going to get plus or minus the square root of 3, and then remember the square and the square root are going to cancel out, so we get x plus 1. And we need to get the 1 on the other side, to the left side. So we subtract both sides by 1. And then we get plus or minus the square root of 3 minus 1 is equal to, and then we have 1 minus 1, which that's 0, so we have x. So this is going to be your answer. X can be the square root of 3 minus 1, or x can be negative square root of 3 minus 1. Those two answers both work. Now remember, we have to find the point, so it means we have to put it in a ordered pair. So we have two arguments. We have the plus the square root of 3 minus 1 for x, and then we have negative square root of 3 minus 1 for x. So we have to do both points. So we have the plus version. Let's do the positive version. So we have the square root of 3 minus 1, comma, because remember, we're substituting this x value for this x value, essentially. And then we have 0. So that's our y value. And then we have the other version. We have negative square root of 3 minus 1, comma, 0. So those are your 2 points where they're on the x-axis and they're 2 units away from the point negative 1, comma, 1. So for this problem, it says find all of the points of the form x, comma, negative x, which are 1 unit from the origin. So let's draw our graph to visualize this. So we have our x-axis, and we have the point x, comma, negative x. So what does this mean? So it means whatever x value we get up here, let's say that it's 1. We'll say x is equal to 1, and we'll plot this point. So if x is equal to 1, we have positive 1 and then negative 1, because that's the form, x, comma, negative x. So when we plot this, we get a point right here. So that's negative, or not negative. This is positive 1, comma, negative 1. And every time you do this, we can try 2. If we get x is equal to 2, we get 2, comma, negative 2. So you're going to notice a little trend here. And then we have positive 2, comma, negative 2. So essentially what's going to happen is this point is going to go down like this. That's supposed to be a straight line. Let me redraw that. It's supposed to be something like that. It just goes a straight line down. So if you keep plotting these points, you'll see the pattern. But essentially what's going to go on is it's just going to go straight down, and it's going to follow a straight line down. So that's how we plot that point. Now we have our other point, which is the origin. So our origin right here is going to be 0, comma, 0. So essentially what we're trying to do is find where this origin and this line right here, even though I drew it bad once again, we want to find where the distance between here and this line is going to be 1 unit. So we have our 2 points, x, comma, negative x, and the origin, which is 0, comma, 0. And then we have the distance between those 2 points, which is 1. So we need to label our points. So for this point, I'm going to label it as x sub 1 and y sub 1, and then the other point is x naught and y naught. So we have d, which is the distance formula. D is equal to the square root of x sub 1 minus x naught squared plus y sub 1 minus y naught squared. So d is 1, so we can replace d with 1. And then we have the square root of x sub 1, which is x, and then minus x naught, which is 0, and then it's squared. And then plus, we have y sub 1, which is negative x, and then minus y naught, which is 0, and then squared. So we have 1 is equal to, and we can square both sides actually. So we can get rid of that square root. So when we square it, we're going to get 1 squared is equal to, and then the square root and the square are going to cancel out. So you're going to get x minus 0 squared plus negative x minus 0 squared. So 1 squared is going to give you 1. And I know before we had a variable which was x or y, and then we had minus or plus a number. So since it's 0, you can simplify that, because you know any number minus 0 is just going to be that number. 7 minus 0 is going to give you 7. So x minus 0, x minus nothing, is just going to give you x. So it's going to be x squared, and then plus, and then we have negative x minus 0, which that's going to give us negative x squared. So then we have 1 is equal to x squared plus, and then negative x squared is going to give you, or negative x all in parentheses squared is going to give you x squared. So we have 2 of the same variables, so we can add them up and say that it's 2 of them. So it's 1 is equal to, So since they're the same variable, essentially it's just 1 plus 1. So 1 plus 1 is 2, so it's going to be 2x squared. And then we need x by itself, so we have that 2 attached to x. So we need to divide both sides by 2. So when we do that, we get 1 divided by 2, which is just 1/2. And then 2 divided by 2 is going to give you 1, so it's just going to be x squared. Now, the next thing we need to do is we need to change the power of x. We need to get rid of that squared because we're trying to figure out what just x is, not x squared. So we square root both sides. So we get plus or minus the square root of 1/2. And then is equal to x. Now we can simplify this answer a little bit more. So what we can do is distribute our square root signs to the top and the bottom. The reason why is because we know what the square root of 1 is. So we get plus or minus, the square root of 1 is 1. And the square root of 2 is just the square root of 2. And that's equal to x. And whenever you have a square root on the bottom of your fraction or on the denominator, you need to rationalize it. And basically to rationalize it means just to get rid of the square root on the bottom. So anytime you have a situation like that, you need to multiply the denominator by itself and then multiply the top by the denominator as well. Because the square root of the square root of 2 divided by the square root of 2 is going to give you 1. So you're not changing the numeric value, you're just changing how it's represented. So we would get 1 times the square root of 2, which that's going to be the square root of 2. And then we have the square root of 2 times the square root of 2, which that's going to give you 2. Because remember, the square root of a number is to the power of 1/2. So essentially it's just 1/2 plus 1/2, which that just gives you 1. So that's why it gives you 2. So don't forget the plus or minus. So we get plus or minus the square root of 2 divided by 2 is equal to x. So that's your answer for simplifying it. Now, the question said for us to find all of the points of the form x comma negative x. So we need to plug x in to find what point exactly is it. So if it's in that form x comma negative x, we need to plug in this x value that I have circled in. So we have plus or minus x. So we're going to do the plus version of x, the positive. So we're going to get the square root of 2 divided by the square root of 2 for the x, and then it's negative x. So we have to put a negative sign in front of there. So we get the square root of negative square root of 2 divided by 2. So that's one of the points. And then the other point is going to be the negative version. So we plug in the negative version right here for x. So we get negative square root of 2 divided by 2. And then we have a negative right here whenever we plug in for x. So we're going to get negative, and then in parentheses, negative square root of 2 divided by 2. And then we can simplify that. So we can write it as negative square root of 2 divided by 2. And then 2 negative signs are going to give you a positive sign. So it's going to be the square root of 2, comma 2. So those are going to be your 2 points where the distance between that point and the origin is going to be 1 unit.